Here we're looking at some special factorization formulas. Now, in case 1, we say that two expressions or two binomials of the form a plus b and a minus b are called conjugates. Now, if we multiply two conjugates together, this is going to produce what we call a difference of squares. So let's take a look. So observe that when we multiply, we have to take the product of conjugates and we apply the distributive property, the two intermediate or middle terms are the same with opposing signs. So they're going to cancel each other out, leaving us with a difference of squares, a squared minus b squared. Now, in case 2, we say that expressions of the form a plus b squared or a minus b squared are called squares of a binomial. And when we take these squares of binomials and we expand them or multiply them, we produce perfect square trinomials. So let's go ahead now and multiply out or expand each one of these binomial products. So I just want to pause for a cause here and point something out. We want to be mindful that a plus b squared is telling us that we are multiplying the binomial a plus b together 2 times. We can under no circumstance distribute an exponent through a sum or difference. So we want to be mindful of those properties of exponents. So expanding the square of the binomial a plus b squared and simplifying, we're left with the perfect square trinomial a squared plus 2ab plus b squared. So let's go ahead now and consider the second case. And very similarly in case 2, when we expand the binomial product a minus b squared and apply the distributive property, we're left with a perfect square trinomial a squared minus 2ab plus b squared. Now I want to make one final cautionary note here and point out the difference between the square of the binomial a minus b squared and the difference of squares. So we want to keep in mind here that a squared minus b squared is not equivalent to a minus b squared. As we can see from above, these are going to produce two totally different binomial products. So we know in expanded form, the difference of squares can be written as a minus b times a plus b. And this is most certainly not equal to a minus b times a minus b. So we want to be very careful here when applying these algebraic properties and be mindful of the rules of exponents.